Hello there, to friend Phil, project management trainer and coach. Welcome to Six Sigma 101. I have with me Dr. Ashraf, who's going to be sharing with us the very basics of Six Sigma. Now, he is an authority in Six Sigma, black belt, having trained many students. So we have the pleasure of listening to a little bit of Six Sigma 101. For those folks who have asked to know a little bit more about Six Sigma. So sit back and watch.
Hi, my name is Muhammad Ashraf, and I'm going to talk to you about a brief introduction to Six Sigma. Before we can even talk about Six Sigma, there is an underlying concept of quality. What quality means and what it refers to. If we have a thorough understanding of that topic, we can go on to what is Six Sigma in my subsequent slides. Quality, as defined by Dr. Armand Feinbaum, quality is a customer determination which is based on the customer's actual experience with the product or service measured against his or her requirements, stated or unstated, conscious or merely sensed, technically operational or entirely subjective, always representing a moving target in a competitive market. The key word here which we have is that the quality is a moving target. The perception of a customer of today of a product might not be the same as tomorrow. The perception of a customer in one segment of the world and a perception of the customer in the other segment of the world of same product might be different. So quality is always judged according to the satisfaction of the customer. That is what we have to do today. What is Six Sigma? Six Sigma is a customer-focused continuous improvement strategy and discipline that minimizes defects and variation towards an achievement of 3.4 defective parts per million in a product design, production, or in a process even. It is totally focused on the customer satisfaction on the front end, and on the back end it is focused on eliminating the cost and maximizing the profit for you who is either a service provider or a manufacturer. Six Sigma, the name as indicates, it has something to do with statistics. We'll be talking about that shortly, but it is more of a methodology, a structured methodology to analyze the problems and to step into solving them. As the logo on top right shows, define, measure, analyze, improve, and control. That is the sequence which we follow, and towards the end of these slides, I will be talking about this process once again. What is Six Sigma? Six Sigma is a customer-focused continuous improvement strategy and discipline that minimizes defects and variation towards an achievement of 3.4 defective parts per million in a product design, production, or in a process even. It is totally focused on the customer satisfaction on the front end, and on the back end it is focused on eliminating the cost and maximizing the profit for you who is either a service provider or a manufacturer. Six Sigma, the name as indicates, it has something to do with statistics. We'll be talking about that shortly, but it is more of a methodology, a structured methodology to analyze the problems and to step into solving them. As the logo on top right shows, define, measure, analyze, improve, and control. That is the sequence which we follow, and towards the end of these slides, I will be talking about this process once again. Six Sigma is focused on reducing process variation using problem solving and statistical tools. Now, what in world is which has no variation at all? You may be waiting in the queue for the bus, and there would be a variation in arriving of the bus there, arriving of the train there. You may be waiting in the queue in the doctor's office, and the waiting time would be varying from 5 minutes all the way to 1 hour. You may be manufacturing a pencil, you may be manufacturing a tire, you may be measuring the pressure of tires in different cars there. Everywhere you will find a variation. So it is up to us that how do we tackle that variation and how do we mitigate that variation in our process. That is what leads to our quality and our customer satisfaction. Again, I will touch variation in my subsequent slides. Six Sigma methods were first perfected by Motorola in mid-1980s there. Yes, Six Sigma has its roots way back 200 to 300 years ago with the advent of statistics, but the name Six Sigma came into being in the 1980s. And it was Bill Smith in 1985 who coined the name Six Sigma. Six Sigma is a performance goal representing 3.4 defects of every million opportunities to make. It may be landings, it may be patient treatment, it may be dispensing of medicines, it may be counting the lost mail items, all that, whatever key quality variable you have in front of you, that's what you have to manage. It gives a series of tools and methods to improve the design of the products, processes, and services. It does not stop at only product. Everything under the sun, you can employ Six Sigma to improve its performance there. It's a statistical measure indicating the number of standard deviations within the customer expectations. That is a key sentence here. I would strongly urge the audience that if they have some confusion of the metric of standard deviation, they should reflect back to their high school mathematics and try to understand what this metric is. Six Sigma is a disciplined, fact-based approach. When we say fact-based, it means that we collect the data of current situation and after we have improved the final situation. Six Sigma is a mean to promote greater awareness of customer needs, performance measurement, and business improvement. Reflect back to my previous slide when I talked about the moving target expectations of the customer. They are always there. Customer is the king of the market, and that's what we have to focus on. Looking at the term Six Sigma, and prior to the Six Sigma, let's look at the term Sigma itself there. Sigma represents the degree of dispersion from the mean, and it is named as standard deviation. So your mean is X, which falls on the mean is M, which falls on the center of your bell curve, and how much far you go on left and right, that is what is this formula calculates for you. The topic of this presentation is not to go into the statistical derivation of this relation which we have here, but I would again urge you to spend some time to understand this formula before we go ahead there. So sigma is one standard deviation, whereas Six Sigma is 6 standard deviations. We will be talking shortly in my next slides how we translate it. So what is this represent? This is a bell curve. Let me get my pointer tool here. So this red curve which you see here, it is a bell curve or a normal distribution. Mu here indicates the target average. The mean, you may be having 1,000 readings, so 1,000 readings divided by 1,000, you get an average there. But the key thing is this sigma part here. The wider it is, the more dispersion you have of your process. The narrower it is, the more focused your process is. What does variation mean? Variation means that the process does not produce the same result every time. And as I spoke earlier, there is no process, no manufacturing, no service in the world which can hit the target every time with the same accuracy. There is some variation in the process every time. The graph here which shows the average value which is here, and then there's up and down variations from the mean. To a conventional mind, you would say that I am meeting my target on the average, but the customer does not care about what your average is. If this part goes to one customer and this part goes to another customer, the earlier customer would be getting a lower spec part, whereas the second customer would be getting the higher spec part, whereas this customer around here would be getting on the target. So there comes the variation there. Customer does not feel the average. He is not concerned about what you are making on average. He is concerned about what he or she is getting. Hence the variation's importance for us. Measuring the process performance, let us take a look at the pizza delivery example. The pizza delivery says, Domino's says, for example, they guarantee a 30-minute or less delivery of the process there. What if we measured the performance and found an average delivery time of 23.5 minutes? My question is it it's on-time performance? We are getting a good delivery time there. Is it correct? Our customers must be happy with this, right? No, we don't know what is the spread. Yes, there might be 20 readings which give the delivery before 30 minutes, but there may be 5 which are going above 30 minutes, and those 5 will be helping you to improve your process. Those are the 5 which you have to target. They are adding to the disperse of your process. Remember, the mean and the deviation, standard deviation, both go hand in hand when you are analyzing the process there. How often we are delivering on time? So let's have a look at this variation. Again, the same bell curve. On the x-axis you see a 0-minute delivery, 10-minute, 20-minute, 30-minute, 40 and 50 there. So what you see here is, to target a 30-minute delivery, you have some readings which are going beyond 30, and under this normal curve, the white shaded portion is which we are failing to meet the customer requirement. That is what we have to address. We have to keep every delivery time below 30 minutes and keep it on target. Managing by the average does not tell the whole story. The average and the variation together show what's happening. Reducing the variation to improve performance. How many standard deviations can you fit within a customer expectations? This is a representation of the same graph for the same bell curve, but with an improved target. Now you see that you are having a much narrower process, and the tail which is going non-conforming to the delivery time is much shortened, almost 1/10 of the overall area under the curve there. So sigma level measures how often we meet or fail to meet the requirements of our customer. The narrower the bell curve, smaller the standard deviation. Smaller the standard deviation, more is the number of the standard deviations within the customer specifications. Another look at the Six Sigma concept. I am trying to hammer this point again and again for the variation, especially since variation holds the key to the improvement. Look at the example there. I can narrate a personal experience. I lived in an apartment for 4 years which had a small garage. The width of the garage was hardly enough to accommodate a Toyota Corolla with some level of comfort, where I was owning a Toyota Camry, a much wider car. Every time when I intended to put the car through the garage, I had to exercise extreme caution that my rear view mirrors don't hit the walls. And then there was the other challenge of me coming out of the car as well. But the example shown here, this is what I mean. Your car is your standard deviation. If you have a narrower car and a bigger garage, you are in a comfortable situation. But if you have a smaller garage, you have to target either go for a bike or go for a smaller car so that you have the wiggle room. Now I am using a big car but a big garage, and I have no scare letting my teenager to park the car as well, because I know that he won't be damaging the mirrors. The concept of Six Sigma here is now look at the tails which are going beyond the specifications and the spread itself. In this process, it shows 3 sigma between the target and the customer specifications. You have a tail which you have to worry about. This tail is the rejections, and within this curve are the acceptance there. You are living in a competitive market there. A little bit of rejection, yeah, if you are talking in 1950s or 1960s, that was the time whatever you produce is accepted. But now there are hundreds and hundreds of players in the same market producing same things, and everybody is striving to get the best customer satisfaction and get minimum scrap, minimum rejection in-house. This is what we have to target. After reducing the variability in the process, this is what we see. It's a much narrower process, and we are having the 6 standard deviations spread between the target and the customer specification. You have wiggle room here. Even if in some cases you go beyond the tail, you still don't go outside the specifications. So let's summarize once again what is Six Sigma. Sigma is the statistical concept that represents how much variation there is in a process relative to the customer specification. Sigma value is based on defects per million opportunities. We'll be talking about that shortly there. Six Sigma is equivalent to 3.4 defective parts per million. The variation in the process is so small that the resulting products and services are 99.99966% defect free. How great is that? As ballpark assessment of the process is too much variation, it is hard to produce within the customer specifications or remain within the customer expectations. That's a low sigma value of 0 to 2, and that shows in the terms of the bell curve. It would be, let me take my pen and I can draw it for you. It would be practically a very low mountain there. Moderate, most outputs meet customer specifications. It's in the middle there. You'll be having some sort of this kind of curve. Very little means very little variation. Virtually all output meets the customer specifications. You are having a very vertical kind of process there. Managing up the Six Sigma scale, up the Sigma scale. So this table shows that number of sigmas crossed with the DPMOs, with the goods and the bads. I will show you what it means here. If my pointer starts working. Okay, so I'm back. There was a bit of technical glitch. So 1 sigma, practically it's a straight line. 2 sigma, there's a bit of bump in the curve. 3 sigma, it's a bit more narrow. 4, 5, 6, and 6 is the narrowest there. Percentage good means within the tails, specifications within the tails. With a 1 sigma, you have very long tails which are going outside the customer specifications. And with a 6 sigma, you have very short tails which remain within the specifications of the customer. Some of the examples of the sigma scale. So in a 3 sigma world, there would be 964 flight cancellations per day. How good is that if you are a frequent traveler? And with the 6 sigma scale, there would be 1 flight cancelled every 3 weeks. That is something which we are living with. In actual cases, I think we are not operating in terms of this metric within to the Six Sigma scale, or not to the 3, it's somewhere between 5 there. So I will let you read through these examples on your own, but the last one is quite critical, second last one. In MA, there are 5,400 newborns dropped each year if the delivery suits and the nurses are following a process of 3 Sigma. That is a lot of angry parents who have their babies dropped, and which may be resulting in fatal injuries as well. Whereas in a Six Sigma process in the delivery suite, 1 newborn dropped every 4 years in MA. So is 1 infant dropped good enough as well? Yeah, if we are talking about mechanical things, yeah, it is awesome. But if you are talking about the life, that is not at all awesome there. That one should not be there even. So that shows that there are some processes which need to be beyond the Six Sigma level as well. Another representation, 3.8 Sigma means 99% is good. 99% gets you an A+ scale in your academics there. So that should be awesome, that should be good. But with 99% good, you still have 20,000 missed articles in every hour in mail, 5,000 incorrect surgical operations every week, 200,000 wrong drug prescriptions each year. So is 99% good enough for these processes? Not at all. You have to go to a Six Sigma level to achieve the customer satisfaction. With 20,000 articles lost in the mail per hour, I think people will be referring back to their horse and cattle days, going to deliver their products themselves to their loved ones. That is a loss of business for the postal service. Looking at the incorrect surgical operations, 5,000 versus 1.7, and even a 1.7 incorrect surgical operation per week is, again, linking it back to the dropped child there, it is of the same scale, same gravity, same intensity. We have to look at to even eliminate this 1.7. That was our brief introduction of what variation is. The variation leads to understanding of the Six Sigma. Variation is represented in standard deviation, and the number of standard deviations between the target and the customer specifications, they show how narrow and how closed process we have, how successful we are delivering on the time. So my next topic to cover is history of Six Sigma. As I mentioned in my first or second slide there, Six Sigma was started when we had the first discovery of statistical processes there. Yes, the name Six Sigma might not be there, but the path was there. It was way back in early 17th century when the normal curve was discovered or introduced by a French mathematician. In 18th century, beginning of 18th century, Gauss used the normal curve to explore mathematical analysis of measurements, probability analysis, and hypothesis testing. That is when he talked about the left tail and the right tail, the specification limits there. Early 19th century, towards the end of 18th century, Italian scientist Vilfredo Alfredo proposed Pareto. So Pareto is something which you will look into in define and measure phases of Six Sigma, where you see that 80% of the defects or non-conformities come from the 20% causes, and then you have to address those 20% causes. Then comes in first quarter of the 25th on the 19th century is Walter Shewhart, who introduced control charts. Control charts is something which you use to monitor the processes. That followed by mid-19th century when DoD introduced FMEA, which is failure mode effect analysis, which talks about analyzing your process through its criticality. Then comes Ishikawa, who introduced cause and effect diagram. It is relating the effects with the multiple causes which we have behind that. Dr. Noriako Kano introduced two-dimensional quality model with 3 types of qualities. And then we come to the later half of the 19th century, which is when Bill Smith, a senior engineer from Motorola, introduces the Six Sigma concept, followed by Allied Signals adopting the Six Sigma, and then GE, one of the major Six Sigma proprietors and the adopters of this century, and taking it to the level of excellence towards the end of the 19th century. Listed are here some of the Six Sigma companies. They are not all. There are even hundreds more than this who are now adopting Six Sigma methodologies to control their processes, to optimize their processes, and to control their variation. Some of the ones not listed here, but they are big names. It is Seagate, it is Cummins, it is Caterpillar is still there. Like you can list a lot of manufacturing companies who have mastered the Six Sigma to their processes, and they are still struggling to get the level of Six Sigma. They are still struggling at the level of 4 to 5 Sigma, not attained the Six Sigma yet. Previous slide was talking about mainly manufacturing companies, the one who deliver a commodity to your hand there, which you can tangibly measure and check. That is not the limitation of the Six Sigma. Look here, we have JP Morgan, Merrill Lynch, American Express, Citigroup. They are all service industries who provide you financial services. They are also very high on Six Sigma adoption for controlling the variability in their processes. The variability in service industries is mainly the correctness of their delivery and the time of their delivery, and they are still working on that. So far we talked about the variation and the concept of Six Sigma. Then we talked about the history of Six Sigma. Now let us touch a little bit on the main methodologies offered by Six Sigma and the corresponding tools. The two main methodologies offered by Six Sigma are Demake, the improvement methodology, and DFSS, the design methodology. First, we will be talking about the Demake, which is the abbreviation of define, measure, analyze, improve, and control. So, in this methodology, you look at the existing processes, the existing things which you have already established, and now they are not delivering to your requirements. You are faltering on your delivery time, you are faltering on your quality, you have a lot of variation in your manufacturing, you have a lot of variation in your delivery times there. That is where we use the Demake methodology to improve the situation. And how does it goes? At the define phase, you define the opportunity, that what needs to be improved, what needs to be elevated, what variation needs to be controlled. You look at the impact of that variation, you look at the impact of that missing opportunities that is covered in the cost of poor quality. You define the problem and you narrow down the problem. Once you have defined the problem, you move to the measure phase. So every problem should have a measurable variable which you are going to measure and control. You need to first establish, are you measuring it correct? Is your measurement system complying to the standards? Is your measurement system, instead of measuring 1 meter, measuring 0.9 sometimes and 1.1 sometimes? So if your measuring gauge is broken, then you cannot fix your process yet. You are driving your car on the highway and your speedometer is broken there. You don't know whether you're going at 100 or whether you're going at 80. The cop comes behind you and gives you a ticket that, sir, you were going at 100. Whereas you say, no, I'm going at 70. My speedometer is showing that. Take a ticket and go and check your speedometer. That is what measure phase is. In the measure phase, you look at your current capability, that to what accuracy, after you have established the measurement system, then you see to what accuracy you are meeting the targets. That leads to the analyze phase. The analyze phase, you look at the individual contributors to the variation there. What are the sub-steps of the process? What are the sub-steps of the component? What are the sub-steps of the service which you are providing? And see the contribution of each step, how it is contributing to meet the final variation goal. After you have gone through the define, measure, and analyze phases, you will come up to a list of improvement opportunities. These improvement opportunities need to be prioritized, highest to the lowest. Refer back to the history I talked about Pareto. Pareto graph or Pareto analysis will show you that 80% of the losses, 80% of the misses, 80% of the defects can be contributed to 20% of the causes. And those 20% causes are the first one to be improved in the improve phase. This is what we do in the improve phase. Now, that might be going and tweaking your machines, that might be going and tweaking your process, that might be going and training your operators and training your service agents there. But it is coming up to you as the leader to see what needs to be done to implement that improvement. Once you have gone through the define, measure, analyze, and improve phases, what good is that if you cannot sustain that? What good is that improvement that it will go back there? Improvement and changing the process is changing the mindset there. People are used to go on the same variation day in, day out there. You have to implement some measures that they don't go back. That once the improvement is in place, people and the machines and the processes gradually don't falter back to the older situation again. That is the control phase, which is one of the most important aspects of Demake methodology. In control, you establish fail-proof procedures, you establish continuous monitoring, you establish auditing, and then you try to monitor that we don't go back and the improvement which is there is sustained for future or to a next level. Once you have, it's a cyclic operation. Once you have gone through one cycle of Demake, you might end up going to a second cycle and improving it further. The second methodology is DFSS. So if you have an already existing process which is producing or which is giving you wrong results, you can improve it to a certain level. Beyond that, you cannot do anything. A car which is giving you a gas mileage of 10 miles per gallon, if it's the older one of a 80s model, you can try to improve. You can fix the carburetor, you can fix the tires, you can fix the driving habits, and you can maybe able to bring it up to 20 miles per gallon. But if you are willing to take it to 40 miles per gallon or per se 50 miles per gallon, you cannot improve that car to that level. You have to design something new. That is where DFSS comes in. DFSS kicks in when you're designing a new process, a new product, or a new service from scratch, or replacing an older process where improvements have limited, we have gone to the limit, you are against the brick wall. That is where you use DFSS. As the methodology and as the essence of this methodology indicates, DFSS would definitely be a longer process because you are coming up with a new design, new service, new process. So you have to be more stringent, doing in-depth analysis. The key to DFSS is collecting rigorous and analyzing the customer requirements which they really need. In my very first slide or second slide, when I spoke about the definition of the quality, customer quality is a moving target. Likewise are the customer specifications there. You start with a new service, you ask the customer that what do you want, you collect the requirements and you start working on those. Halfway through the working, you come up, the customer comes to you and he says, I want to add on this thing. Do you have the liberty to say no to him? Well, there it's your leadership and your capabilities employing the DFSS methodology to translate the customer requirements into critical to quality parameters there. The critical to quality parameters dictate what is the basic requirement of that facility which you're going to provide to the customer. And on top of that, you rank the requirements. These are the essentials ones, these are the ones which will make him happy, and these are the ones which will make him wow. I can give you an example of somewhere around 2005 and 2006, when you had the first iPhone there. iPhone was the one to come up with the new concept of touch screen and the swipe features on the screen there. The customer had never expected these things to be there. The customers were always happy with having touch buttons there, pressing the buttons and doing their function on the phone. That took the phone and the handheld gadgets to a new level. That is how you wow the customers there. So DFSS, you start with the customer requirements, you translate them into the critical to quality parameters, and then you look into the methods how you can incorporate a Six Sigma level quality into those critical to quality parameters. So far we have covered the variation concept, the concept of the Six Sigma, what a Six Sigma process means and what are the failures there. We talked about the history of Six Sigma. We talked about two major methodologies and the key tools used there. Definitely a 5-minute or 6-minute talk on a Demake method or a DFSS method does not make you a master in that. We do need to talk about these methodologies into detail, which I will try to cover in my subsequent lectures. Again, that will not make you a certified black belt, but that will give you a thorough understanding what you're talking about. The Six Sigma realm in any company has certain players. Those roles and responsibilities we can talk next. Champions. Champions in some manufacturing companies or in some service industries, champions are the ones who have to lead the implementation of Six Sigma. They are also the master black belts. They are the front end of Six Sigma in any industry. They identify potential Six Sigma improvement projects for the company. Usually what they do is that they look at the quality aspects of the industry and see what is hitting them most. And then from that, they translate that into projects and start addressing them. They identify the key players, the leaders who can be good black belts and good green belts. And the third final job of those guys is to train the black belts and to mentor them through their projects. They are supposed to be the specialists in Six Sigma. That follows with black belts. Black belts which has been since the conception of Six Sigma in late 80s and early 90s, is one of the elite group of people who master these tools and who have the leadership skills. Black belts keep that in mind, they are not expert in every process. They are not expert in gas chromatography. They are not expert in financial analysis. What they are expert in is delivering the methodology from DMAIC and using the appropriate tools to analyze the variables. They have to play as a team leader with the team members who are supposed to be the experts there. Mark my words here, black belt is not supposed to know every technology under the sun there. They need to lead the team, they need to steer the team to the common goal of minimizing the variation. They are dedicated for 100% for their whole time is dedicated for Six Sigma improvements. They have no other chores. So they have different projects. One project in one time might be from financial services and the other project might be at the manufacturing floor, eliminating the scrap there. So they have to be ready to go into both ends of the industry. They are also Six Sigma knowledge leaders within the business units. They undergo a 4 to 5 weeks of training spanned over 5 to 6 months or sometimes 10 months there. The DMAIC 5 phases are each one has a 1 week of training, in-depth training for the tools, and between each phase there is a gap of 3 to 4 weeks. They start with the project, go to the training, implement the first phase, go to the training, review the first phase, and then next to the next phase. then to the next. That is definitely for their first project. Once they have that mastered that methodology, they are on their own to do this work. Green belts. They use the same methodologies, same structure as black belts, but green belts are embedded into their functions. When they are, maybe a green belt is functioning as a financial analyst, or a green belt is functioning as a manufacturing engineer. He or she will be doing his projects in his dedicated space. So the difference between green belt and the black belt is the depth and the breadth of the projects there. Their projects are more dedicated to their area. Otherwise, their training and the knowledge of tools is definitely similar to black belts. There are two other roles, subject matter experts. The subject matter experts, they provide dedicated knowledge on some of the tools there. They are supposed to be your professors. As compared to that whenever you're stuck in a problem, you go to the subject matter experts and ask their advice how to use such and such tool, how to get the translation of such and such data, how to understand the implications of the data there. And finally, the financial controllers. So, Six Sigma projects definitely result in two kinds of savings. One is the saving which is hard saving. You can tangibly feel that saving into your balance sheets. You have eliminated some scrap, you have eliminated some workforce, you have eliminated the warranty cost, you have eliminated the return of the parts to you from your customers. That all sums up into the hard cost which shows in your balance sheet. However, there is a secondary saving as well. What if we did not do this project and the product had gone to the customer, and from that customer to the second level of the OEM supplier, and the engine had failed on the road? There would have been a big impact of the cost which have trickled back to you there. What if we did not move that improvement, the warranty cost jacked up to millions there? So that all sums up under the avoidance cost. What if we don't do this thing? Now we have done it and we are improving it. You map the failures in time and you mitigate how much saving you have achieved if you would have gone on that road there. Financial controllers are the people who help us to analyze the financial impact. One is saving, one is financial impact. Saving is the hard number which shows in your balance sheet, and financial impact is what would have gone wrong if you had not done this improvement. That brings me to the end of this presentation. We talked about Six Sigma, the definition of variation, how standard deviation translates into the defects and the rejects of your process, not meeting the customer requirements. We spoke about the bell curve, we spoke about the tails which get out of the customer specifications, and those are the tails which we have to bring in the process by minimizing the variation, by minimizing the spread. We spoke about the history of Six Sigma, when it started, when it came to its current shape, and where it is now. We spoke about the two main methodologies, Demake and DFSS, which are available for there. Demake is for improving the existing processes, whereas DFSS is for designing new processes. Then we spoke about role and responsibilities, champions, master black belts, green belts, financial controllers. At this point, if you have any questions, definitely channel them to your moderator and he will bring them back to me. And in my subsequent lectures, we'll start addressing each module individually and talk about some major tools which are covered in that. Thank you. Hi, my name is Muhammad.
I hope you found the presentation informative. Remember, it's just the top of the waves. There are 5 more episodes to go, and we will be bringing you those episodes as the weeks go on. Thank you very much for joining, and those of you who may be PMPs, remember you can always get Six Sigma training at sixsigmamindpro.com. It's a great place to begin. Dr. Michael Harry is someone I know and was affiliated and associated with Mr. Smith in Motorola back in the day. So I would highly recommend Six Sigma Mind Pro if you're looking to get Six Sigma certified, green belt, black belt. Dr. Michael Harry will set you straight. Thank you very much, and we'll hear one more message from our visiting professor about the PMP exam. Don't go away.
Hi, my name is Muhammad Ashraf.
Here are the 6 key tips for your project management professional exam from Praizion Media. Download the PMP handbook and read it. Go for a great PMP exam 35-hour course. Complete your PMP exam application. Study hard and don't fool yourself. Take the Praizion mock exams at www.praizion.com. Take the PMP exam and pass the PMP exam. Many project managers start off on this journey, but very few complete it. You must be mysticated to see it through to the end. Call now and invite us to train your project managers at 480-545-2022. And now I must go prepare for my next lecture on leadership.